All right, get ready to get your socks blown off because we're talking about wind. All right, so today's notes are on wind, and wind is everywhere, and it is pretty much air, isn't it? Wind is a large mass of moving air that goes from a place of high pressure to a place of low pressure. That's all it is. It's air that is moving. But you probably never asked yourself, I wonder why. Well, now you know that air moves from a place of high pressure, which means that the particles are really cool. And so when particles are cool, you know that the particles are closer together, making them heavy and cold. And they want to move to a place of low pressure, which is light and fluffy and warm, okay? So another word for a chunk of air or a mass of air is called a front. And there are two kinds of fronts. There are cold fronts, which are heavy and dense, and they move fast, okay? Because there's a lot of them and they're all squished together. So it would be like a 200-pound guy versus a 20-pound person, okay? A warm front is obviously going to move much slower because they're much lighter. Here is a diagram that shows a warm air moving in, and this warm air is called a front. So this is a warm front, and we know that warm air comes in and pushes out the cold air. Now the cold air moves out very slowly because it is dense. Here you have the cold air moving in and pushing the warm air out. And remember, cold air moves very quickly when it's coming in. You do not have to draw these pictures. I'm just showing you this so that you can use it again if you decide you want to watch the video again. But these are the two kinds of fronts. We have a warm front and we have a cold front. Here's another picture. The cold air mass, or the cold front, is moving in and the warm air mass is getting pushed out. Same here with the warm air mass coming in. And notice that the warm air kind of moves above the cold air because the cold air is thick and dense, okay? And what you'll notice every time you see the warm air hitting the cold air or the cold air meeting the warm air is that you start to have stuff happening here. So what do moving cold and warm fronts cause? They cause weather. They cause storms, such as snowstorms, rainstorms, thunderstorms, tornadoes, typhoons, hurricanes, everything that is weather, right? So any storms, any weather that happens is because a cold front or a warm front is moving in. Now, we got to get down to the details of what causes wind, okay? There are two things. One is the difference in air pressure, which we've already discussed. It's the high going to low. And what causes this is the sun. And we're going to talk more about that in a second. These cause local winds, winds that are just in the area, okay? There is number two, the Earth's rotation. We love the Earth's rotation. Not only does it give us day and night, it gives us global winds. And that means that on top of the local winds that we have in our area, we also are subjected to experiencing global winds, winds that go across the entire Earth. The sun causes changes in air pressure, okay? So how does that happen? All right, let's talk. So first of all, we know that when the sun hits the Earth, it doesn't heat it 100% the same all over the Earth, right? We know that it hits directly mostly on the equator and then unevenly, indirectly at the poles. So this creates an uneven heating of the Earth. And what we know, whenever the sun heats the air, we know that hot air rises. Hot air, we know, are like molecules of gas. And those gas molecules like to zip out all over the place. And because they keep pushing each other away, they're zipping all over the place, they are less dense. They don't want to be close together. Okay? The second part is that when the hot air rises, as it goes higher and higher in the sky, we know that as altitude increases, the molecules gets colder up there, okay? And when it gets colder, then things start to cool down. And when things start to cool down, you see the molecules, they get closer together, they get slower, and they start to sink. For example, here's my little picture. Okay, so when hot air rises, it gets cold up here because we know that as altitude increases, the temperature decreases, and so the particles get cold and then they fall. Then when they fall back down to Earth, the air here that is at the Earth is getting heated by the sun. They get hot again and they go back up. And then they get cold. And you see the process of this whole cycle of getting hot, getting cold, and this creates local winds. Okay, so what you see here is my pretend globe, right? It's my Earth, and the heat is rising, the heat is falling, the heat is rising, the heat is falling. This is also happening on the other side. The heat is rising, the heat is falling. And of course, notice here the molecules are going up and down, up and down, up and down, all over the world, everywhere. Now, there are two kinds of local winds that we have, and let's take a look. The first one is called a sea breeze. If you've ever heard sea breeze, there's a reason why it's called sea breeze, because in the daytime, we know that the land heats up faster. So, when the land is heating up faster, you have the land heating up here, so the warm air is rising, and as it rises, it goes out this way because it's getting pushed by the cold water. The air above this water right here is cooler, so it pushes in from cool to warm, right? Because it goes from high pressure to low pressure. So it moves this, which then moves the air going up, and then it cools, and then it goes into the circle. And this is called a sea breeze because the breeze is coming from the sea. Therefore, you get the word sea breeze. The other kind of local wind is called a land breeze. And obviously, this tells you that in the direction of this picture right here, instead of a sea breeze coming in from the ocean to the land, it goes from the land to the ocean. And the reason why is because at night, the land cools faster, so you have cold going out to hot. So you get the direction of the breeze going in this direction, and then of course the warm air is rising, and then it gets pushed over and then cools down and goes out this direction and just keeps circling this way. So if you live near an area that has a large body of water, you are going to experience two kinds of breezes. One is the sea breeze, and then as the day goes on and it becomes nighttime, you're going to get the breeze going in the opposite direction. So there you go. You get two different kinds of local breezes or local winds. The next one is, how does Earth's rotation create wind? We discussed already sun. Now we need to talk about the rotation. How does the rotation create the wind? This causes global winds. Now this is different, okay? It actually makes the wind curve, creating pockets of wind around the Earth. Now that might be a little weird to imagine, okay? So let's just go ahead and write this down, that the Earth's rotation creates wind. It creates global winds by making the wind curve. Now, this is also known as the Coriolis Effect. Let me explain. So we already know that as the sun hits the Earth here at the equator, that it makes the air warm, and as the air warms, it rises up in the sky and gets cold and then goes to the colder part, which is the poles, right? So it goes from this hot rising, cooling, sinking down. So we get this. This is if there were no rotation in the Earth. Okay, this is what the wind would look like. But notice these lines here. This is also going up and down, up and around. This would be the wind if there were no rotation. Now, we know that the Earth rotates in a counterclockwise position. Because of this, this line moves. It looks like it moves because the world is turning. The wind that would otherwise be going straight would go this direction. And the wind that would be coming down from this bottom south pole would go up and kind of go to the left. So it creates this effect of all these arrows of wind going in to the center of the equator. Okay, so what that looks like, and that phenomenon is called the Coriolis Effect. This is what you would get, and of course you don't have to draw any of these pictures, but you would get all these pockets of air. And notice here that the wind is blowing in a different direction, and this is all due to the Coriolis Effect. You do not have to know this picture. You do not have to know that the arrows go in this direction and the arrows go in this direction. You just need to know this, that the Coriolis Effect, the rotation of the Earth, causes global wind by making the wind curve. This causes global wind. Okay, that's all you need to know. And that's pretty much it for the TNOTES. Please make sure you understand this, rewatch the video if you need to, and be ready to use this in class next.